We are back. I don't know if you guys noticed in that last video, the sun was setting, and so it was getting kind of tough to see towards the end. But now I got my lamp rocking, and there's probably going to be some shadows as I kind of move my hand around, but I'll try to avoid that as much as I can. Let me pull my light a little bit closer. Okay, so moving on, we just completed practice number 2. No, excuse me, we just did number 3, so we're moving to the next page. It's the main characteristics of a distribution on the lecture document. So it says, once displayed in a graph like a histogram, you will be able to see 3 important aspects of the distribution of the data: the center, the spread, and the shape. Okay. So we're kind of taking a different angle here. We're not what's coming up in these main characteristics. We're not graphing anything like a bar graph or a histogram, but we're calculating important numbers that tell us something about the center, the spread, or the shape. There is another type of picture we will learn when it comes to the spread, actually, but most of this stuff is just like some number crunching and taking like averages and that sort of thing. Okay, and that's actually where we begin. So think there's these 3 big characteristics: the center, the spread, and the shape. So what do we mean by measuring the center? So it turns out there are 3 ways that we can think about the center: the mean, the median, and the mode. And these are the same mean, median, and mode that you may have learned about in the past. But if not, hey, we're going to do them again. So the mean. The mean is the average of the data values. All right, so the mean of a sample has a special notation. We call it x bar. It's literally the variable x with a little bar across the top. It's denoted x bar, while the mean of a population is denoted, and that is a Greek letter. It looks like a U with like this extra tail in front. That you pronounce mu. Let me write that here. So we've got x. Oh man, these shadows are really pronounced here. That's okay. Well, it is what it is. So this we would read as x bar, and this we read as mu, mu, the Greek letter. And so again, what are those? Well, this is the average for a sample. This is the average of a population. Okay. So to calculate the mean, well, it's an average. So we'd say x bar is the sum of all the data values in the sample, add them all up, and then divide by how many there are. Divide by the number of values in the sample. And I give a formula there, but I think that description in words is probably a lot more helpful for people. I would say that's true of me as well. Or if you're talking about mu, the average of a population, we take the sum of all data values in the entire population and divide it by the number of them in the population. Same idea, sample versus population, right? Okay, so then here I say capital X denotes a data value and N denotes the sample or population size. That's if you're looking at those other formulas, although I would say in this case, it's helpful for them to be here in the lecture if you need to reference those again for whatever reason, but let's just go with those verbal descriptions of these things. Okay, practice number 4. We're looking at that great white shark data again, but now we're going to calculate the mean. So calculate the mean great white shark length, and we're going to have to round to 3 decimal places. Okay, so here we go. Now the first thing to ask yourself for number 4 is, should we represent this average with x bar or with mu? And obviously you see what I have written there. Why would I choose x bar to represent the mean of these great white sharks? Well, do these 16 great white sharks Is that a sample or is that a population? And I think we can imply here this is a sample. If we say the mean great white shark length, we don't have data for every great white shark in the world, at the moment. We just have a sample of these 16. Okay, so we're going to use X bar because it's a sample average. And what we're going to do is we're going to add up all of those lengths and then divide it by 16 since there are 16 of them. I will spare you adding those up. Now, obviously, in your homework, on your projects, that sort of thing, you're going to have to do this sort of stuff. But I think I've communicated the message. If we add all those 16 numbers together, I've gone ahead and done that already. You'll get 271.6. And you're going to divide that by 16. And when we round to 3 decimal places, you get 16.956. Now I've done it on my calculator here. And for some reason, okay. You have to pardon me. I'm definitely not going to reshoot this video. I just got to make this correction. For some reason, I thought to double check myself, and I actually made a mistake. It should have been 271.3. That's where we get the answer. My mistake. I miscopied something. Now that makes sense for anybody who's checking my work out there. Okay, but I think we get the idea. All right, next up is the median. Let's define the median. After the data is listed in order, the median is the number that separates data into halves. And when we say halves, we mean half of the values are the same or smaller and half are the same or larger. And guess what? We're going to calculate the median great white shark length. Okay, let's do it. Let me get rid of this. It's not. Okay. So in number 5, to compute the median great white shark length, first thing we need to do is to put this data in order. And obviously that's the definition, right? After the data is in order. So this takes some time. Again, it's tedious, but that's the way it goes for now. I've gone ahead and done this already. 16 data values takes a little bit of time to pick through and get them all in order. But there they are. 12.3 we know is the shortest. And then it goes up from there. So I'll let you guys take a moment, copy these, right? 13.2, 13.3, 15.8, 16.2, another 16.2, 16.4, 16.5, 16.7, 16.8, 17.8, 18.6, 18.7, 19.1, 20.9, and 22.8. And that's all 16 sharks. Okay, once they are put in order, then we need to find the number that separates the data into halves. So here's how we do it. We're going to start at the outer edges and then work our way to the middle. And what you often see people do is crossing off numbers on both ends. So we'll cross off the first data value and cross off the last, and then the next, and the next, and the next, and the next, and the next. And we're just going to work our way down towards the middle. And we see, oh, we don't want to cross both of these off because then what would we have left? So as we started crossing those off, we worked our way down to these two at the center. Well, what do we do if there's not one number at the center? And well, we actually take the average of those two numbers right there. And so I've got that at the bottom. We will average 16.5 and 16.7. So add them and divide by 2. And well, you'll get 16.6. So that's the median right there. The median shark length. The shark length that would divide, if we'd like, sometimes you see people draw a line here. That line would have 8 sharks below and 8 sharks above. And the number right between those two numbers is 16.6. And so now this is a very different way of thinking about the center of the data, right? So sometimes it's more appropriate to use an average or a mean. Other times it's really much, much more appropriate to use a median. Okay. Finally, we get to the mode. The mode is the value that occurs most frequently. The most often occurring data value is the mode. What is the mode of the great white shark lynx? And now that we've even seen them all listed in order, we can probably pick out the mode, and maybe you know it already. It's the 16.2. Now this really isn't all that interesting for the shark data. 16.2 occurs twice, and no other data value occurs more than once. So 16.2 is the mode. It turns out very seldomly is the mode used in the classical sense, like in the sense of this definition. More typically, we're going to use the mode in a slightly different way. We're going to see that in the second half toward the end of this chapter. But just have that in mind, that a mode means it's occurring the most frequently. Okay. Moving along. Those are the 3 ways to measure the center. Now we're going to measure the spread on the next page. And we see here we're going to get to know another way of representing the data as a picture. Okay, so we begin with the range. We define the range of the data as the difference between the lowest and highest values. Take your highest value and subtract your lowest data value, and that gives you the range of data values. Makes sense. Okay, then there's the quartiles. What are these quartiles? Well, you think quartile, you think quarter. We're going to end up cutting the data into 4 equal parts. The 3 numbers that separate ordered data into equal-sized quarters, denoted Q1, Q2, and Q3. And you may notice that the second quartile, which we call Q2, actually is the median. So the Q2 will divide it into equal halves, and then Q1 and Q3 will further divide it in half. So we'll have it cut into 4 equal-sized chunks. And finally, there's the interquartile range. The IQR, as it's referred to usually, is the difference between the third quartile and the first quartile. And so you would literally do the calculation Q3 minus Q1. Now, why is that important? It gives the range of the middle 50%. So we're going to see this all these things a lot better as we do examples. So let's take a look at practice number 7. We're going to calculate the range, the quartiles, and the IQR for both of these data sets. Okay, let's start with part A. And well, I'm revealing the first answer already. So in part A, let's calculate the range. Well, what is the range again? The range is the difference between the lowest and the highest values. So we need to start with the highest. The highest data value from that raw data in part A is 50, right? And the lowest value is 5. So we'll take 50 minus 5, and here the range is 45. Now, in this practice problem, we don't know the context, right? We don't know what those numbers, where they came from, what they represent. That's fine. We're just working with, these ideas of the range and the quartiles and such. Okay, so the highest data value minus the lowest gives you a range here of 45. Now let's get to the quartiles. How do we do these quartiles? Okay, well, we need to put the data in order, just as if we were calculating a median. So that's what we need to do next. Okay, so I've taken the time. It's tedious, but a little bit smoother than the shark data. Put these numbers in order. So it would be 5 first, and then 6, and then 12, 13, 15, 18, 22, and finally 50. Okay, and now we can really see that range, right, from 5 up to 50, a range of 45. All right. How do we get the quartiles? Okay, so we're going to begin just the same way we begin, by taking the median. So we're going to find uh, the position that cuts this data into equal halves. So if we have 8 data points, well, let's see, 1, 2, 3, 4, and counting down 1, 2, 3, 4, it's going to be this number. I'm just going to draw a line right there between them. Now, what would be the median? Well, what's halfway between 13 and 15, right? Well, of course, 14. And we're going to call it Q2. So turns out the median does not have like a special notation like the mean does, right? The mean, we say like x bar or mu. Well, because the median has the notation Q2, and so people just use that. All right, once we have Q2, now we're going to go and find Q1 and Q3. So looking at the lower half, let's do it again. Cut it in half a second time, and that's going to fall between these two values. All right. Well, what would that make Q1? What's halfway between 6 and 12? Well, if you add them together and divide by 2, that would give you 9. Or maybe you can tell it's 9 anyway. All right. And to get Q3, we're going to look at the upper half, divide that. There's Q3 right there. Well, what's halfway between 18 and 22? Got to be 20, right? And so there are the 3 quartiles. Q1 equals 9, Q2 equals 14, Q3 equals 20. And you see we have divided this into 4 equal parts. 1, 2, 3, 4. Each of them has 2 data values. There you go. Finally, the IQR. Well, once you have the quartiles, the IQR is pretty fast. Very similar to the range, but now we're taking Q3 and subtracting Q1. So while the range does the entire data set, the IQR tells you how far it is between Q1 and Q3. So 20 minus 9 equals 11. And that's it. Now, what is that IQR really doing for us? And it said back in the definition, this is the range of the middle 50% of the ordered data. So the IQR, if you know the range and you know the IQR, you really have a good idea of the spread of the data, right? We're all about measuring how spread out is this data. You think, okay, well, how spread out is it from end to end? Well, it's 45. But how spread out is it just in the middle 50%, right? Those middle 4 data points, how spread out are those? Oh, those are only spread by 11. So these are all pretty closely positioned together compared to the whole thing. And really the reason behind that, of course, is the 50. The 50 is so much bigger than anything else in this data set that makes a big range compared to the IQR. And that's, we're getting some insight into how spread out these numbers are. Okay, let's stop this video here, and we will do another one coming up.